Who is hungry? We made a bundt cake out of a parabola. If you take that parabola 3x minus x squared, starting at x equals 0, curving around to x equals 3, and that parabolic shape bounded by the x-axis, if we revolve that around this axis of revolution, which is the line x equals -1, we get a bundt cake. Yum! So if we're going to share this bundt cake, then we're going to need to cut it up. So if we think about the strategies we've done in the past, we've always had these perpendicular cross sections, right? All of our radii were measured from the axis of revolution. I stressed that because people tend to forget it. So I might find a small radius and I might find a big radius. And we realize, okay, yeah, that means that we've got a washer method, right? Cross sections perpendicular to the axis of revolution, but with a hole in the middle. It would be the disk method, except there's a hole in the middle because bundt cakes have a hole in the middle. So yeah, we've got a regular old washer problem, right? dy here and dy here, and we've got two radii, right? We've got one radius that we'll call big R, which is a function of y, and we've got a smaller radius, little r, that is a function of y. And to find these, we do right minus left, right? So this would be whatever the curve is minus -1. That's our x value, right? So we're taking the x value on the right side minus the x value on the left side. And then we do the same thing here. We do this curve minus -1 for the little r value. So what is the x value in terms of y? Well, the weird thing that's going on here, and we saw this a little bit before when we were finding areas, is the right endpoint of this rectangle and the right endpoint of this rectangle actually exist on the same curve, on the same function, y equals 3x minus x squared. But since we are trying to figure out what an x value is in terms of y, we now have to take this equation and solve for x. Okay, so we'd have x equals something in terms of y. Now, x would not be a function of y because we've got two different x values for a given y value, right? For example, with the y value equals 0, we get an x value of 3 and an x value of 0. So we actually have two different equations of x in terms of y. And we'd have to use the quadratic formula to solve for x in terms of y, and that plus or minus in the quadratic formula would allow us to have the right half of the parabola and the left half of the parabola. And it's messy, and it's terrible, and it makes us sad. It's definitely possible, and you can try it if you like, but the disk method, or the washer method in this case, is not really the best way to find the volume of this bundt cake. Think about this in the real world. Would we ever slice this cake horizontally? I mean, maybe you would if you wanted to be weird, but most people wouldn't want to take this disc at the top and slice it off and give that to someone. First of all, you wouldn't get much cake. Second of all, you need a huge plate in order to accommodate such a big circle that's so skinny. And then people's slices of cakes would get bigger and bigger and bigger as we got down to the bottom of the cake because the outer radius is getting bigger while the inner radius is getting smaller. So the person at the top gets the short end of the cake. And the person at the bottom is going to eat too much cake. So the moral of the story is we do not want to use the disk method to find the volume of this cake. We want to use something different. So instead of using these cross sections that are perpendicular to the axis of revolution, we're going to nix that idea. That's too hard, too messy. And we're going to try a different method. This is going to make our cross sections parallel to the axis of revolution. Okay, so with these vertical little slices, then we've got, instead of a dy problem, we're back to our more familiar dx problem. Okay, and we've got ourselves a height, right? I'll call this h, and we've got ourselves this r value. We'll call this r. And when we revolve this rectangle around the line x equals -1, we get this shape right here. Right? You could call it a washer, I suppose, because it is a cylinder with a cylindrical hole on the inside. But it's not a washer because washers are very, very flat, right? The height of the cylinder of a washer is that infinitely small thing. Whereas here, this is the height of our cake. right? The thing that's infinitely small here is the thickness of the wall. So this is not really a washer. This is more of a shell, okay? So shells result when the cross-section is parallel to the axis of revolution. So remember we had perpendicular. Now we're going to have parashell, right? The shell method is when the cross-section is parallel to the axis of revolution. So we need to figure out, excuse me, we need to figure out the volume of the shell. Remember that the volume of a cylinder with a cylindrical hole is just the volume of the big cylinder minus the volume of the small cylinder. So if we can figure out the volume of that big cylinder and the volume of the small cylinder, we'll just subtract them. Okay? Well, the dx that's happening here turns out it's easiest if we kind of split that dx in half. So let's zoom in on this cross section. This is still dx right here. And we could use a radius of r and then another radius of r plus delta x and use our formulas for that. But turns out it's nicer if we kind of slice this in half and pick r to be right in the middle of the wall of the shell. So r is going to be right here. And then our delta x value, it could be delta y in some cases, but in this case it's a delta x. Our delta x value, we're going to add half a delta x to get to the big radius, and we're going to subtract half of a delta x to get to the small radius. So keeping that in mind, we can come up with a volume formula for the generic cone is base times height, right? The base is a circle, pi r squared, times the height. So in this particular case, we're going to have for our big cylinder, we have the volume equals pi times r plus 1/2 delta x. Whoops. That's our radius, so we'll square that, multiply it by our height. We've got the volume of our small cylinder is same thing with a minus. And when we expand these out, well, I'll leave the pi and the h factored out because those are similar to both of these. But we've got r squared plus, well, 2 times r times delta x over 2 gives us r delta x. And then we've got delta x over 2 squared, so that's delta x squared over 4. Okay, and then we get the same thing down here, except instead of a plus rx, we get a r delta x, we get a minus r delta x. Everything else stays the same. So that's just how you square binomials, nothing fancy there. So when we subtract, right, we're doing volume of the shell equals the big volume minus the small volume. We're going to take this small volume and subtract it from the big volume. So the volume of the shell equals, we still have that pi and we still have that h, and the r squared minus r squared goes away. We've got r delta x minus a negative r delta x, that's plus a second r delta x. And then we've got a delta x over, squared over 4 minus delta x squared over 4, so that goes away as well. So the volume of our shell is going to be, well, take a look. We've got 2 pi r, that should sound familiar, times h times the thickness of delta x. Okay, so circumference shows up here, times the height, right? That's going to give us the surface area of a cylinder, and then we have to multiply by the thickness. So so that would be our new formula that we're dealing with. It's no longer big radius squared minus small radius squared. It's now 2 pi rh delta x. Now that's the volume of one shell. We're going to add up all of them, and then we're going to let that delta x approach 0, so our approximations get better and better and better. So we end up getting this new formula that tells us that our volume of our bundt cake, is the integral. Well, we've got a 2 and a pi, so let's factor the constant out first, the 2 pi. We're going to integrate this for all of our x values. So x starts at 0 and goes to 3, so from 0 to 3, of our radius, which is a function of x, and our height, which is also a function of x, and then our delta x, that as we take the limit, that turns into a dx. So the only thing left to do is to figure out what is our radius and our height at a generic x value. So we go back to our shape and we realize that the radius is measured, so it's a horizontal distance, so to find the distance we do right minus left, right? So our right endpoint is starting at 0 going to 3, but it's our variable x. Our left is -1, so our radius is going to be x minus -1, right? This is the right minus left to find the horizontal distance. For our height, we do top minus bottom, and that's our height here. This is the top is y equals the parabola, 3x minus x squared. The bottom is the horizontal line, y equals 0. So f of x minus 0 in this case, or 3x minus x squared. And that is, and then the dx, of course, that is the integral that sets up the volume function to find the volume of the bundt cake. Okay, and that's something we can evaluate by hand for sure. We'd have to distribute, right? Binomial times binomial, so we'll get a massive integral that we can deal with, but I'm not going to do that on the video because these videos get too long as they are. But this is something that you can evaluate by hand and check in a calculator. Before I finish off this video, though, I want to pay attention to this other question that was posed. It says, what would happen if the graph was rotated about the line x equals 4 instead? So x equals -1 is 1 unit to the left of our parabolic shape. X equals 4 is 1 unit to the right of our parabolic shape. Now, so these are kind of in the same place, these two possible axes of revolution. And the shape is symmetrical. So you would imagine that if we were to take the same shape and revolve it around this line instead, we would end up with a congruent bundt cake. It wouldn't be the same one because it would be shifted to the right instead of shifting it to the left. But it would definitely give us the same sized bundt cake. So how would that change things? Well, the only thing that would change would be our radius. Our radius is no longer measured right minus left being x minus -1. Our radius would now be right minus left 4 minus x. So give it a try. See what would happen if we changed our radius to, instead of x plus 1, x minus -1, let's try 4 minus x. That would be another possible way to find the area of the bundt cake, and it would give us the exact same value. Give it a try. You can do it by hand, or you can try it in a calculator. I recommend both. This would be if the axis of revolution is x equals 4, whereas the original one was the axis of revolution of x equals -1. Now, of course, if we change x equals 4 to x equals 5, for example, then that would not give us the same answer because now we'll have a bigger radius that this bundt cake's cross-section is going to swing around a bigger circle, so we'd get a much bigger cake. So the volume would increase the farther away this axis of revolution was to the cross-section. So play around with that and see what you come up with, and yeah, and then enjoy your cake.